All right, so for trig, so far what we have is the fact that angles in a triangle add to 180 degrees. If you have a right angle triangle, you've got the Pythagorean theorem, or you've got your SOHCAHTOA, your primary trig ratios. And then if you don't have a right angle triangle, you have the sine law. And the sine law works when you have an angle and a side across from it. So in this first example, we're going to solve for angle C. Here we have an angle and a side across from it. We have the side B. Our first step is that we're going to have to solve for angle B, and then we can get our angle C after that. So give that a shot with the sine law, and then we'll take that up. All right, so I've written the sine law in terms of side B and side A. I filled in what I knew and multiplied both sides by 95 right here. I got what the sine of angle B is equal to, but to get angle B by itself, we have to undo the sine by doing that second function sine, or inverse function sine. And I got angle B being about 51 degrees. So when I want angle C then, angle C is going to equal 180 degrees, subtract the 110 degrees, and subtract the 51 degrees. And that gives me an answer of 19 degrees. All right, now we want to solve for side F. So side F is always across from the angle labeled F, so I need this one. And the only side length I have is the 19.5, which is across from angle E, which means I need to get angle E, which is easy enough to do because I have two angles in my triangle. Angle E would be 180 degrees minus the 70 degrees and minus the 30 degrees, which is going to give us angle E being equal to 80 degrees here. So we can fill that in, and now we can solve for side F. Since it's a side I want to solve for, I'm going to put side F on the top. That's going to be over sine of angle F, and that's going to equal the side E over the sine of angle E. So you can fill in what you know and solve. So F over the sine of 70 degrees would be equal to 19.5 divided by the sine of 80 degrees. Throw that, before I throw it in the calculator, I want to get F by itself. I'm going to multiply both sides by the sine of 70 degrees. Sine of 70 degrees. Throw that into the calculator. You always want to make sure your calculator is in degree mode for these, because those are the units that we are using here. And I'm just multiplying this out, and I got 18.6 approximately here, and that's going to be meters according to my units there. Now that makes sense. The biggest angle should have the longest side across from it. So the biggest angle is the 80 degrees. It has the 19.5. 70 degrees is slightly smaller. Its side length across from it's 18.6. The 30 degree angle, side D, is going to be the smallest side length if we were to solve for that. All right, our last example here for our warm-up is solving for side H. So side H is across from angle H, so that gives me this. And then I have two sides here. I have side I, but I don't have angle I, and I have side G, but I don't have angle G. And because I only have one angle H, I can't solve for G or I, angle G or angle I here. So this is a case where our sine law does not work. Okay, so our sine law does not work here. To use the sine law, you have to have an angle and a side across from it, and then one other piece of information. So the sine law does not work for this one. So we're going to learn this new thing called the cosine law, but here we're going to summarize when you can use the sine law. So you have to know an angle and a side across from it, and then one other side or angle, like we had in part A and part B. Because we did have that, we did have to do a little bit of extra work in terms of getting to the answer we knew, but sine law worked for that. So let's take a look at this new thing called the cosine law. All right, our cosine law is a little bit more complicated than the sine law. This is the formula here. Okay, so it starts out, if you look at the very first part here, it reminds me of the Pythagorean theorem, which works with right angles. But because we're using this for a non-right angle triangle, we have to do some extra stuff to it. So we have this extra minus 2ab times the cos of angle C. You'll notice a couple of patterns here. So your side C is by itself, so C squared, it's matching with this angle C. So those have to be across from each other. And then in the middle, we have an A squared plus B squared, and then we're taking away 2AB. So the things in the middle stay in the middle, the things on the outsides stay on the outside. The cosine law can be used in the example we just had, where we have two sides and the contained angle, the angle between them. The other time it's used is when you know all three sides and no angles at all. But we're going to leave that for part 2. That'll be tomorrow's or the next lesson after this one. So we have the summary. Your cosine law can be used when you know two sides and the contained angle. And if you're a picture person, that means you've got your triangle. I'm a picture person, and you know, like little a, we'll call it little b, and you know the angle between them, so I'll call that angle C. So that's the case where you have number 1, all two sides in the contained angle, or you could know all three sides. You could know A, you could know side B, you could know side C, but you have no angles given to you at all. All right, so we're going to determine the length of the unknown side here. Our unknown side would be little d across from angle D. And we have that case where we have our two sides and the angle between them. So it's little d I want to solve for, and I know angle D. So when I set up that cosine law, I want to use little d squared is going to be my other two sides squared and added together, so e squared plus f squared. I'm going to take away 2 times e times f times the cosine of angle D. So that's my formula. I've just used the letters for this triangle as opposed to the C's, A's, and B's that I have in the formula up at the top of the page here. I'm going to fill in what I know now. I know side E is across from angle E, so that's 15.8. That's going to get squared. Plus side F, which is 12.1. That's going to get squared. Minus 2 times 15.8 times 12.1 times the cosine of angle D, which is 115 degrees. Now, I strongly recommend putting this into your calculator all in one foul swoop. So on my calculator, I don't have a fancy one. I'm just going to go 15.8 squared plus 12.1 squared minus 2 times 15.8 times 12.1 times, and then I have to do my angle 115 and then hit cos, and then I'm going to hit equals. Now out of that I get 557.64 approximately. I'm leaving all those digits on my calculator, and I'm going to square root that answer, and I get about 23.6 as my side D. And it's across from 115 degrees, which would be the biggest angle in that triangle, and clearly we have D being the largest side. All right, let's see what else we can do here. We want to solve this triangle. Remember, solve means find all the missing side lengths, all the missing angles. And again, because we have this pattern of two sides and the contained angle here, my only option is to use sine law. So the angle H was given. That means I can solve for side H across from the given angle. I'm going to have side G and side I. G squared plus I squared minus 2GI times the cosine of angle H. So I'm rewriting that formula in terms of the letters of the triangle, and then I'm going to fill in what I know. Side G across from angle G, side I across from angle I. Fill this in. We're going to have 12.8 squared plus 9.9 squared minus 2 times 12.8 times 9.9 times the cosine of 78 degrees. And again, put that in your calculator in one foul swoop. 12.8 squared plus 9.9 squared minus 2 times 12.8 times 9.9 times, I'm hitting 78, and then cos, some of you will just do the cos of 78 degrees, equals, I get 209.1, round that up, rounds to 1/6. Approximately, h is approximately equal to, I want the square root of that, 14 point, ooh, that's going to round to 5. So h is 14.5 centimeters. Now, solving means find all your missing information. So at this point, we still need to find angle G or angle I. Now that we have angle H, or sorry, side H is 14.5 centimeters. Now we can use our sine law because we have an angle and a side across from it. We could use a side and the angle across to solve for that angle across. So I'm going to put the angle on the top because that's what I want to solve for. The sine of angle G over G is equal to the sine of angle H over H. Put that information in and solve, and then you can use the angles to add up to 180 degrees here to get the remaining angle. Put the video on pause and try it. Alright, so I've used my sine law. I got angle G to be about 60 degrees, and then I used the angles in a triangle, add to 180 to get that angle I is about 42 degrees there. So hopefully that makes sense. The next lesson will be what to do if you've got all three sides and you need to solve for the angle.